Hello and welcome. So you're taking a look at previous notes that we have. So this is polynomial, so unit 4, and previously 4.8 was applications of zero product property. You have these notes. We're going to actually now go ahead and attach some problems that were from Pizzazz page 106 to the back of this, and I had given you guys a sheet in class that had the problems. So we're going to skip through the work that we've already done, so vocab here, and then now the applications method. So first we want to read the problem, making sure we can sketch and label a picture if necessary, identifying the unknown items. Then using appropriate background info, so if there's a model, some type of formula that we need. We can go ahead and apply the zero product property in order to solve, so that's where we would set one side equal to 0, factor it if possible, and then find the reasonable solutions. Once we have those reasonable solutions, we're going to go back and answer the original question. So now we're going to take a look at the worksheet that you got in class, which is Pizzazz 106. Again, we're asked to solve the problems below. The hint is to consider using the zero product property to help you solve. So number A in your packet says the length of a rectangle is 3 more than the width. The area is 70 centimeters squared. Find the dimensions of the rectangle. Now we're going to do a drawing because it's always best to draw and label a picture if possible. So I'm going to take a look and I'm going to make a rectangle. And this rectangle should be roughly 3 centimeters more in length than its width. So I'm going to label the width x, and we always take the length to be the longest side. And I'm going to add it as x plus 3. Again, that's my length because it's the longest side. So now we're going ahead and saying, well, I know the area of this guy, so the inner area, is actually 70 centimeters squared. So now that I've labeled this drawing, I'm going to go ahead and kind of work through what I know. And I know that the area formula is the same thing as length times width. So I know that really 70 centimeters squared should be equal to x plus 3 times x. I'm actually going to make that a little neater. So let me go ahead and do that. So x plus 3 is that length, and x is my width. So using the distributive property, I'm going to go ahead and simplify and end up with 70 is equal to x squared plus 3x. Now to use zero product property, I need to get 0 on one of the sides. Makes sense because I want my x squared to be positive, so it already is. I'm going to move this by subtracting 70 from both sides. That then gives me a 0, which is very good news because that's what we wanted. So 0 is equal to x squared plus 3x minus 70. Now I'm going to go through this process and factor this quadratic equation. Again, I have an x squared plus 3x minus 70. If I was to use my decision tree, it would tell me there is no GCF. It also would tell me that I have 3 terms. And the first term coefficient is 1. So that tells me I have third term factoring that I'm working with. So in doing that, I'm going to find the factors of negative 70 that add to a positive 3. So that's going to tell me if I had a negative 7 times a positive 10, when I add those together, I in fact do get what I'm looking for of this positive 3x. So then I can break this guy up and give myself x squared plus negative x plus 10x minus 70. Again, still having that equal to 0. Now that's a step that we can skip if we would like to and go directly down to the step that provides us with the binomials of x minus 7, and x plus 10. Again, this is the factored form. Using zero product property, I'm going to write two equations that allow me to do this. I'm running slightly out of room, so I'm going to move this guy. So it's a little bit smaller, giving myself just a little extra room. Now you should have enough room on that page, but if you do not, you are welcome to attach an extra sheet of lined notebook paper. And I'm going to write two separate equations. So zero product property tells me that each factor has a possibility of being equal to 0. So in order to solve this, I get 7 is equal to x by adding 7 to both sides. And I can subtract 10 from both sides here and get x is equal to negative 10. Now we really care about the reasonableness of these answers, and since a length or a side length is not possible to be negative, we're actually going to ignore that one and work with x is equal to 7. So normally if we were to write this using zero product property, we would say with a squiggly brackets, the solution was 7 comma negative 10. But here, the only solution that's reasonable is 7. So if I go 7 plus 3, I get 10 for that side length and 7 for that side length. A quick check, just multiplying those guys together, will indicate if I'm in close proximity. And in fact, when I multiply, let's use a dot rather, 7 times 10 with parentheses, it in fact does give me 70. So the area seems to be checking out just fine. We do want to write a sentence to answer the problem, because the problem wasn't what is the area, but it asked us to find the dimensions. So here I'm going to write a sentence to say the dimensions of the rectangle were 7. Let's get their rectangle. Are 7 centimeters by 10. Oops, let's make that look like a 10 centimeters. Excellent. So now we've got this concept going, and we are going to head to the next one. So B asks us, let's switch gears. So we're going to have you try B on your own. This is the length of a rectangle is 4 more than the width. The area is 96 centimeters squared. Find the dimensions of the rectangle. Now, this is very close to what we just previously did in A. So if you're not sure what to do, the wording is almost the exact same with a couple of differences with the actual lengths that are changed. So, go ahead, pause the video at this time and try out B. Alright, thank you for trying out B at this time. If you weren't able to do it, make sure you pause the video at the end and go back to letter B. Moving to C, we are going to discuss the this one in the video. So it says the length of a photography, which really is supposed to say of a photograph. Gotta love when auto check doesn't catch that stuff. So let's make this of a photograph. You could also just get rid of the Y. Is 1 centimeter less than twice the width. The area is 45 centimeters squared. Find the dimensions of the photograph. So I'm going to, after I've read this, I'm going to draw a picture that matches. And again, you don't have to be accurate with this. It just is important for us to recognize what our options are. So if I know that the length, and again that is my longest side, is 1 centimeter less than twice the width, I'm going to label the width as x and the length as twice, which is 2 times the width, and subtract 1 because it is 1 less than that. And let's actually include the less than so we can really understand what's happening. So that's a huge piece there. And when we use less than, remember we need to flip-flop which goes first. So we have to have the x go first because it's being, 1 is being taken away from what already exists. Alright, so now that we've gotten the drawing taken care of, we get to organize the area. So I'm going to also plug in here that the area is equal to 45 centimeters squared. And go ahead and kind of fill in the gaps that I have. Again, still using the concept of area is equal to my length times my width. And we know the area to be 45 and the length to be 2x minus 1 and the width to be that x. Now I'm going to use a distributive property like I have been to simplify and then solve using zero product property. So this tells me 45 is equal to 2x squared minus x. I'm going to subtract 45 from both sides just to organize one side equal to 0. There are no like terms, so I get to move ahead and I just get myself to have 0 is equal to 2x squared minus x minus 45. Now on the factor decision tree, I'm going to look to see if there are any GCFs amongst this polynomial. And in fact, I do not have a GCF. So I'm going to check and see there are 3 terms, so 1, 2, 3. And the first term has a coefficient not 1, so I'm going to use reverse FOIL. That tells me I'm going to multiply the first and third term together. And I'm looking to find a factor pair that adds to -1. So if I pick 9 and -10, that's a factor pair that adds to -1. Since I'm using reverse FOIL, I need to put these into a box, so I am going to separate this out. This gives me 0 is equal to 2x squared, and this is going to be plus 9x minus 10x minus 45. Now, all 4 of those terms are going to be placed inside a visual FOIL box, so let's do that now. Always place my first term here, my middle terms that are broken up in the diagonal, and my last term right there. Taking a look at this, I'm looking to find the GCF. So why don't we pull out the GCF in orange. In the first row, I only have an x. The second row, I do have a like term of, or excuse me, a greatest common factor of -5. In the first column, I have a 2 and an x. And in the last column, I have a +9. Double checking, as always, is a good choice. We're going to make sure that these multiply and check out before I move on. And that then indicates that we're in good shape, and I'm going to write down my factored form of 2x plus 9 multiplied by x minus 5. Again, those are the two quantities in my factored form. I'm going to write two equations here. Because zero product property tells me that if I'm multiplying, the factors can be set equal to 0. So then solving this first one of 2x plus 9 is equal to 0. I unfortunately know already that it's going to be negative because I'm going to subtract 9 first. And since I don't want to work with a negative number, I'm going to leave this guy after I have him. So this just tells me that x is equal to negative 9 halves, or negative 9 over 2, otherwise known as negative 4.5. Since I left that guy alone, I really don't need to worry about him. I'm going to add 5 to both sides over here, and I get x is equal to a positive 5. Now that's the one that makes the most reasonable sense, as we are working with this concept of length and measurement, and really we don't have such a thing as negative measurement. So my answers, while are still negative 9 over 2 and 5, the only reasonable answer that we're going to work with is x is equal to 5, again because it's positive. Now let's go back over to the original, and if I know that x is equal to 5, because that's the most reasonable item, here if I plug in 5, I end up with the answer of 10 minus 1, which is 9. So then it's telling me the dimensions are going to be 9 centimeters by 5 centimeters. If that's what I'm working with, I am going to check out that if I multiply 9 times 5, I'm hoping to see that it provides me with the solution. And in fact, it does check out. Because if I multiply 9 times 5, I get 45. So in the fashionable form, we're going to write a sentence to say the dimensions. Of the rectangle are 5 centimeters by 9 centimeters. Excellent. Wonderful. So now we've taken a look at A, B, and C. Hopefully you've tried B on your own. If not, go ahead and try it at the end of this video. D is the next one that I'd like you to try on your own, and is also very similar to what we just worked on. So D is one of those unique problems in which you don't need the zero product property to find this out. In some cases, we really don't need to use the zero product property. This is an example of one of them, indicating that if the sides of a square are increased by 3 meters, so I'm working with a square that's measured in meters, the area becomes 64 meters. So I'm just reading this problem, and I know the area is 64 meters squared, and that the side is increased by 3 meters. If that's the case, the only way that I know about squares is I know that each side of a square is the exact same. So the answer, I'm telling you, is 5 meters. You can find this by realizing that all sides of a square have the same length. So if you think of a number whose square is 64, you can come up with 8 times 8. Explain why the side of the original square is 5 meters if the larger square has side lengths of 8. This is what I'd like you to do for this problem. So rather than having you solve the problem, I want you to explain how that works. And again, I've got this square whose side length is the same for all of its sides. Let's see if I can make another square that might look sort of appropriate. That's pretty close. And I want to know the side lengths of the original square. Please provide an explanation for why I know the side length is 5 meters when the larger square has side lengths of 8 meters. Okay. Now let's take a look at E, which I would like you to try on your own. It says a square field has 5 meters added to its length and 2 meters added to its width. The field had an area of 132 meters squared. I'll help you sketch a picture for this. And you can draw and use the zero product property for this one. So we start out with this square field, and then we extend it 5 meters on one side, and 2 meters on another. So when I label this, it's going to start out having the square has dimensions of x because they have to be the same. And the length was added by 5. And the width was added by 2. Now take a look at this, and it tells us that the field had an area of 130 after it all came about. So this area inside the field, the entire area inside it, let's see if I can indicate that. After we made the extensions of 5 meters on one side and 2 meters on another, was 130. Meters squared. So take a look at that and work through that. The zero product property should help you out there. And let's take a look at F. This is our last video that we're going to do, or the last problem in this video that we're going to do together. So F says the dimensions of a garden were 5 meters by 5. Oh, excuse me. Let me rephrase this. The dimensions of a rectangular garden were 4 meters by 5 meters. Each dimension was increased by the same amount. The garden then had an area of 56 meters. Find the dimensions of the new garden. So again, I'm going to draw a photo or a sketch of a drawing of this. And if that was my original garden of 4 by 5, I can even just label that immediately. The dimensions were increased by the same exact amount. So I'm going to draw yet another rectangle. And how wide, I don't want to make extras of those. How wide I have it is going to be the same as how, like, the extension is the same exact amount I'm extending both the length and the width. So I can just put x in that extension. It's the exact same. Even though I don't know what it is, it's still x. So then in doing that, I know the new area is 56 meters squared. So I get to do, and this is very similar to E, which I asked you to try on your own. So if you had trouble with that one, pay close attention to this, and let's move into looking at that. So again, the area inside here we've identified as all of this in here, the whole thing, as being 56. So I'm going to write this in here so we have it. Is 56 meters squared. So I'm going to go ahead and write that all out. Again, if I know area is equal to length times width, I'm going to say that 56 is equal to my length, again, which is my longest side, so it has to be the 5 plus x, times the width of 4 plus x. Now I need to FOIL this and then go through the process of zeroing out one of the sides. So when I go through the process of FOILing, I get 56 is equal to 20 plus 5x plus, and I still need to FOIL, so I'm going to go ahead and FOIL the second part, which would give me 4x plus x squared. I'm going to put that all together and reorganize because I always like to have my highest exponent in the very front as my first term. So simplifying this down, I'm going to recognize that I have this concept of 56 is equal to 20 plus 9x plus x squared, and then reorder it, where I then have 56 is equal to x squared plus 9x plus 20. I'm going to subtract 56 from both sides so I can use the zero product property, which is always fun. And here I do have a like term that I can combine this with. So this gives me 0 is equal to x squared plus 9x, and it's going to be minus 36. Now when I go through the process of factoring, there is not a GCF. And there are three terms, and the first term is a coefficient of 1. So I'm going to use third term factoring. So negative 36 allows me to have a negative 3 and a positive 12 in order to add to a positive 9 but multiply to a negative 36. So when I write this into my factored form, I write x minus 3 and x plus 12. I get to go about two separate equations using the zero product property. And I only care about the one that is positive. When I add 3 to both sides, I find that x is equal to 3 for this problem here. And that's a great thing because it's positive. So over here, I'm going to subtract 12 to both sides just to make sure that I don't have two possible answers, because that could be likely. But in fact, I don't. And I'm going to be able to cross this guy out because he had a negative value. And in this application, I can't have a negative measurement length. That then tells me that I'm going to be adding 3 along with the 5. And 3 along with the 4. So when I come to look at this length, it becomes 8. And this length becomes 7. To check that out, I can multiply 8 times 7, and in fact I do get 56. So I know that that checks, which is excellent news. Again, all I did was plug in where I see this x, I made it a 3. So 4 plus 3 became the 7, and 5 plus 3 became 8. Awesome. So from here, we just need to write our sentence, and we are finished. So this asked us find the dimensions of the new garden. So the new garden has dimensions of 8 meters by 7 meters. Lovely. All right. Thank you for your attention. Please do try the 3 items on your own. Again, one of them is already completed for you. So you should be completing B. D just asks you to write a sentence as to explaining why that works. And E is a try on your own. Very similar to what we just did in this example F. Thank you again for your time. We'll see you in class and go over those items in class.